Hello everyone and welcome. I am Atharva Gadre and I welcome you all to another video of the video series How to Solve Logical Reasoning Questions given by the Axis Maths Club of MIT Academy of Engineering. Today we are going to see how to solve upstream and downstream questions. Upstream and downstream questions are mostly related to boat and river type questions, so these are also called boat and river questions. So let's solve one example of each. In this, there are two categories to find distance and time, and another category is to find speed. So we are going to solve one example of each. Let's see the examples. Here, sorry, let me just erase this. Here, a speedboat whose speed is 15 km per hour in still water goes 30 kilometers downstream and comes back in a total of 4 hours 30 minutes. What is the speed of stream in kilometers per hour? So there is no shortcut for these type of questions. So what you want to remember is that you have to increase your solving time and do it as quickly as possible. So just focus on the things that are given to you. Like 15 kilometers per hour is the speed of the boat, 30 kilometers it goes downstream, so it has to come back upstream 30 kilometers. So the total distance traveled is 60 kilometers and the total time taken is 4 hours and 30 minutes. Let's solve the question. Now, the speed of the stream, that is the speed of the river, let it be x, as that is what we have to find. Going downstream means going in the direction of water. So the total speed of the boat increases as it is going in the direction of water. So that is 15 plus x. And upstream, vice versa, it gets reduced. So 15 minus x. So we can say that the boat travels in both directions. So the total time taken would be 4 hours and 30 minutes. That is upstream time plus downstream time. So the downstream time would be 30 by 15 plus x, that is distance upon speed. Similarly, the upstream time would be 30 by 15 minus x, that is the distance upon speed. So let us name these equations 1 and let us name this equation as 2. So what we have to do is we have to add these two equations to get the total time. So this is what and this is the result when we add the two equations, and on the right hand side would be 4.5 hours. You can also write it as 9 by 2 hours because that would be easier to solve. And when you solve these equations, the LCM on the left hand side would be 900 divided by 225 minus x square equal to 9 by 2. So when you solve this, you get 225 minus x square on the right hand side and 200 on the left hand side, as 900 is divided by 9, 200 and is multiplied by 2 to get 200. So again, we take the x square on one side and 200 on the other side, we get 25. And when we do the square root of this, that is obviously 25 square root is 5. So we can say that x is 5. So the speed of the river is equal to 5 kilometers per hour. Next question is, a boat is moving 2 kilometers against the current of the stream in 1 hour and moves 1 kilometer in the direction of the current in 10 minutes. How long will it take the boat to go 5 kilometers on stationary water? So we have to find the speed of the boat. So we have to find the time taken by the boat to travel 5 kilometers in a non-motion water, that is still water. So as the question depicts, let me highlight, it travels 2 kilometers against the current, that is it is traveling 2 kilometers upstream in 1 hour and it moves 1 kilometer downstream in 10 minutes. So we can say that the total speed of the boat, including the speed of the river and speed of the boat in still water, is 6 kilometers per hour. How we reach to this conclusion? As you can see that it travels 1 kilometer in 1 by 6 hours, that is 10 minutes. So 1 by 6, this 6 goes up to here, so this comes 6 kilometers per hour. Similarly, it is traveling at 2 kilometers per hour. So this is the equation when we are going upstream, and this is for the downstream. So 2 kilometers per hour, as it travels 2 kilometers in 1 hour, that is equal to 2 kilometers per hour, right? So let us say this is equation number 1 and equation number 2, right? So let us assume that the speed of the boat is SB, like we have assumed here, and we will be substituting this equation number 3 into equation number 1 and 2. So equation number 1 and 2 becomes like this. right? Downstream, that is speed of the river, is 6 minus SB and SB minus 2. So we have to remove SB as we have to find the speed of the river. So we have to remove either one of those variables. So we will be removing SB. For removing SB, simply add these two equations. We'll be adding them and the result would be SB and SB gets cut. Speed of the river, that is 2 into speed of the river, let's say it's SR, is equal to 4. 6 minus 2 is 4. So speed of the river comes out to be 2 kilometers per hour, right? 2 kilometers per hour. I'm sorry, the writing is bad. I'll just remove this, right? So we can say that the speed of the river comes out to be 2 kilometers per hour. Now, if the speed of the river is 2 kilometers per hour and therefore the speed of the boat in still water would be 4 kilometers per hour, right? So speed of the boat in still water would be 4 kilometers per hour. So we can say that if we have to travel, now what the question says, that we have to travel 5 kilometers in stationary water. Stationary water, that is the water is not moving. So we can say that we have to move 5 kilometers and the speed of the boat is 4 kilometers per hour, right? Kilometer per hour. So the time taken would be distance upon speed, right? So we can say 5 by 4, which would be equal to 1 hour and 15 minutes. 15 minutes. That's it in today's video lecture about upstream and downstream. We'll be meeting next time in another video lecture for solving another type of logical reasoning questions.